Okay, so we had a little technical error, so now I'm having to kind of redo this video, so sorry it's late getting up there. But the good news is that we can go ahead and I have all the information already filled out. I'm just going to kind of run you through the words here, and we'll walk through it together. All right, so an exponent is a small superscripted number that shows how many times a symbol or a number is to be multiplied. We talked about that earlier. In this example here, we have x to the 5th power. Their base is x. Your exponent is 5. That represents x times x times x times x times x. Okay, I think that you know that pretty well. We talked about that a little bit in class today. For the next one, we have 2 to the 4th power, where the base is 2. The exponent is 4. And that's the same thing as saying 2 times 2 times 2 times 2, which equals 16. All right. Now, again, that's information that you should have gotten from today's class, and you should understand from the activity that we did in class today. But in order of operations with exponents must be done before multiplication or division and addition or subtraction. Operations with exponents follow their own specific laws. 2 of these laws were reviewed in the previous activity. So what we did today in our activity, we talked a little bit about the negative exponent law. We talked a little bit about the law of zero exponents. But just to kind of recap that, the law of zero exponents says that for any number except 0, so for any number x except 0, x to the 0 power, any number to the 0 power is equal to 1. So 5 to 0 is 1, 10 to 0 is 1. Anything to the 0 power is 1. The law of negative exponents is that for any number x, except for 0, 0 is the exception in most cases, x to the negative a power is the same thing as saying 1 over x to the a power. Okay, remember we said that negative sign makes us flip it. Okay, so in this case here, we have x to the negative 4th power. Well, we flip it and make it 1 over, because remember there's understood x over 1 over x to the 4th power. And that exponent now becomes positive. What happens here? Look, what if we start with 1 over x to the negative 4th power? When we flip it, we end up with x to the 4th power. Again, the negative goes away over 1, which is the same thing as saying x to the 4th power. You need to be able to go both ways on this. Okay, those are things we kind of touched on today. Now you have a specific law to memorize. I highlighted this so that you could memorize these things. All right, let's look at our notes. Let's look at this table down here. It says, and I kind of cut to the chase here, use a calculator to complete the table. 2 squared plus 2 to the 8th power, that equals 1024. 2 cubed plus 2 to the 7th power, well, that equals 1024. 2 to the 4th times 2 to the 6th power, that equals 1024. 2 to the 5th times 2 to the 5th power, that equals 1024. And 2 to the 10th, that's right, it also equals 1024. So what do you notice about the answers to each of these problems? Well, the answer is 1024. What else do you notice about the base of each exponential expression? They all have a base of 2. What patterns in the exponents do you notice? So look at the exponents. What do you notice here? 2 and 8, 3 and 7, 4 and 6, 5 and 5. Okay? If you look beyond the fact that each one is going down, or this column's going up by 1, this column's going down by 1, 2 plus 8 is what? 10. 3 plus 7 is 10. 4 plus 6 is 10. 5 plus 5 is 10. So in any case, all of these end up being 2 to the 10th power. And 2 to the 10th power we now know is 10 to the 20, or 1024. Okay? So, we're working on creating a rule here. What happens? Well, will the pattern work if we're investigating expanded expressions? Complete the following table to determine if the rule determined for multiplication of exponents is justified. Okay, so what we're trying to figure out is if we add the exponent, is it always going to work out? Well, let's see. 3 to the 2nd power times 3 to the 4th power, 2 plus 4 should be 6. Well, let's expand it. 3 times 3, that's squared, times 3 times 3 times 3 times 3, that's to the 4th power. How many 3's do we have being multiplied here? 1, 2, 3, 4, 5, 6, which is the same thing as 3 to the 6th power. What about here? 2 to the 6th times 2 to the 7. If we just add these exponents, it should be 2 to the 13th power. Well, let's see. 2 times 2 times 2 times 2 times 2 times 2, that's 2 to the 6th. Times 2 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 is 2 to the 7th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It is 2 to the 13th power. Okay, 7 to the 3rd power times 7 to the 5th power should be 7 to the 8th power. Let's see. 7 to the 3rd, 1, 2, 3. 7 times 7 times 7. 7 to the 5th, 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6, 7, 8. 7 to the 8th power. 12 to the 2nd power times 12 to the 3rd power should be 12 to the 5th if we just add 2 plus 3. 12 times 12 times 12 times 12 times 12 is 1, 2, 3, 4, 5. 12 to the 5th power. X squared, 1, 2. X to the 3rd, 1, 2, 3. 1, 2, 3, 4, 5. X to the 5th power. 2 plus 3 is 5. So, like we've talked about, and like you all know, if we're multiplying all these numbers together, it's the same thing as raising it to a specific power. So if I take x to the 8th power times x to the b power, then I have x a plus b. That's our rule right there. That's our law. So what does the exponent mean in each expression? Well, it represents how many times we multiply the base to get our answer. So let's come up with a law. On part B, it says, write a conjecture or a rule explaining the process of multiplying same bases raised to the power. Key here is same bases. Same bases. Okay? So, what we can say is when you multiply numbers that are the same base raised to powers, you keep the base and add the exponents. So, I'm multiplying same bases. 3 is a base, 3 is a base. Those are the same base. So I'm going to keep the base over here, which is 3, and add the exponents. 2 plus 4, which is 6. Oh, I guess you can't see that. Let me come back down. Let's look at this one. Same base, 12 times 12. Those are the same base. We're going to keep the base over here, which is 12. And now I'm going to add my exponents. 2 plus 3, which is 5. So when multiplying the same base, I can't stress that enough. Same base, same base, same base. When multiplying the same base, keep the base, add the exponents. And then if you need to, if the problem tells you to, you can figure out what 12 to the 5th power is by using your calculator. This is called the multiplication law of exponents. I highlighted that so that you would memorize that. You need to memorize these. There's nothing that's going to be given to you that you're going to have this. You have to commit these to memory. It is extremely important. It'll be on your next quiz on Friday. So multiplication law of exponents. All right, let's look at the next table. Well, what's happening in the next table? It's the opposite of what we were doing. Earlier, we were up here at the top, we were multiplying. Now we're dividing. I bet you can, if you took a second to figure it out, I bet you can figure out what's happening without looking ahead. So here we're doing 3 to the 4th power divided by 3 squared. So 3 times 3 times 3 times 3 divided by 3 times 3. Well, what we did today in class, we canceled those out, right? That leaves us with 3 times 3, which is the same thing as saying 3 squared. And if you hadn't already figured out, what are we doing here? Same basis. We are now, instead of multiplying and adding, we are dividing and subtracting. So 4 minus 2 is 2. Let's look at the next one. 2 to the 7th power. 1, 2, 3, 4, 5, 6, 7 2's over 1, 2, 3, 4, 5, 6 2's. Cancel out what we can. All that's left is 2 over 1. Which is the same thing as saying 2 to the 1st power. Or 7 minus 6 is 1. 7 to the 8th power is 8 sevens. 1, 2, 3, 4, 5, 6, 7, 8. Over 7 cubed is 3 sevens. 1, 2, 3. Cancel out, cancel out, cancel out. That leaves us with 1, 2, 3, 4, 5 sevens. So 7 to the 5th power. Or 8 minus 3. 12 to the 6th. 1, 2, 3, 4, 5, 6. 12 squared, 1, 2, cancel out, leaves me with 1, 2, 3, 4 12s, or 12 to the 4th power. Or 6 minus 2 is 12 to the 4th power. So our rule is, if you have x to the any power a divided by x to any power b, it's going to be x a minus b. That's the rule. Okay, it says, what does the exponent mean in each expression? Again, it's the same thing as we set up here. It is the represents how many bases that we have, how many times we're going to multiply. That didn't change anything, so I'm not going to rewrite that. Now it says write a conjecture or a rule explaining the process of dividing same bases raised to a power. So what we do is just like multiplying, we say when you divide numbers that are the same base, again, same base, that's a huge key word, same base, raised to powers, you keep the base and subtract the exponents. This is our division law of exponents. Again, I highlighted this because you need to commit this to memory. So, same base is being divided, keep the base, subtract the exponents, 4 minus 2. The base is the same as this, all these, 4 minus 2. All right, let's keep moving. Make sure you commit these to memory. And so last page notes. So what we've covered so far, what we just figured out on our own was a few laws of exponents. We have the multiplication law of exponents. Again, the bases must be equal. Then you add the exponents. So here's our textbook example. X to any power a times x to any power b equals x a plus b. So here's our examples. We need now pay attention to the directions here. It says give the solutions in exponential form and numeric form if possible. So pay attention. Sometimes you're going to do both. Sometimes you're going to do one or the other. Okay, so 2 squared times 2 to the third power. Again, same bases. Add the exponents. So that's 2, keep the base. 2 plus 3, 2 to the fifth power. That's the work that you would show, which is the same thing as saying 32. If you do 2 to the fifth power in your calculator, that's 32. 4 squared times 4 squared. Again, like bases, that's important. That's a must. Keep the base 4, add the exponents. 2 plus 2, 4 to the fourth power, or 256. Over here, x cubed times x to the fifth power. Base is the same, they're both x. 3, keep the base, x, and add 3 plus 5. And then you get x to the 8th power. Okay, then you have your division law of exponents. Again, the bases must be the same or must be equal. Then you subtract the exponents. Here's our textbook example. X to any exponent a divided by x to any exponent b is the same thing as saying x a minus b. So 3 to the 10th divided by 3 to the 5th. Again, we're giving solutions in exponential form and numeric form. 3 to the 10th divided by 3 to the 5th. The bases are the same. Keep the base of 3, subtract 10 minus 5. Then you end up with 3 to the 5th power, which is 243. Okay, now here's one that combines two laws that we know. Let's do it here. X to the 11th divided by x to the 24th. Same basis. Now I subtract. Make sure you subtract in the right order. Top subtracted by the bottom. So x, 11 minus 24. If you do this out of the wrong order, you're going to have the wrong answer. 11 minus 24 is negative 13. Now, one thing that we haven't really stressed yet is you cannot have a negative exponent. You cannot have a negative exponent because we have a law of negative exponents. We talked about that earlier, or the inverse law. This negative tells me to put a 1 on top and move it to the bottom and make it positive x to the 13th power. That goes back to that first page where we talked about the law of negative exponents. All right. C is even more tricky. In fact, it gave us a warning. Be careful with C. How could you rewrite the problem so the bases are equal? Because look here, when we start this problem, 2 to the 6th power divided by 4 squared. Do they have the same base? No. You have to create your bases to match them. Okay? So what I did was I turned that 4 into 2 squared. Because 2 squared is still 4, right? Well, there's my 4. And then I have to still raise it to the 2nd power. Well, when I raise it to the 2nd power, it comes out to be 2 to the 4th power. Because what happens is when I raise a power to a power like that, I multiply those two little numbers together. We'll talk more about that in a second. So now I have 2 to the 6th power over 2 to the 4th power. Okay, same basis now. Now I can subtract. So 2, 6 minus 4. Well, 6 minus 4 is 2, so 2 squared, which is 4. I know this is complicated, but we're going to have to learn to combine our exponent laws. We're going to do that tomorrow. I'm sorry, the next day. Okay, our next video is over that, extending the laws. All right? Let's look at our power laws of exponents. This is what we just talked about right here. This is where this comes from, this particular law, what I was doing right there. The power law of exponents, also I call it the power to a power law. Make sure the inside value is an exponential form. If it's not an exponential form, that means if you just have a number, you need to raise that number to a 1. Okay, that becomes your exponent. Like I said, that's the understood exponent. The outer exponent multiplies times all the inside exponents. Anywhere there's an inside exponent inside the parentheses, if it's on top, bottom, wherever, you're going to have to multiply everywhere. And we'll see more of that later. So here's our textbook example. X to any power A raised again to any power B is the same thing as x to the a times b power. Earlier when we were multiplying like bases, we added. Now we're not dealing with like bases. We're dealing with one base now, a power to a power. We're going to multiply. Remember, exponents can only multiply times other exponents. You're not taking this exponent a and multiplying it by this, or the exponent b and multiplying by this. You're just multiplying exponents times exponents. Okay, you got to remember that. So here's some examples. Again, we're getting solutions in exponential or numeric form and numeric form. So here's the first one. This is the same thing as, okay, so what if I did this? A lot of people, I'm going to scoot this up. A lot of people will try to do 2 squared to the 3rd power by saying, okay, 2 squared is 4, and then 4 to the 3rd power is 64. But what we want to do here is say, okay, I always circle these so that I know to multiply them. So 2 times 2 raised to 2 times 3. Well, 2 times 3 is 2 to the 6th power. 2 to the 6th power is 64. Same answer. It's just applying our laws of exponent. You need to learn how to apply that law because it's going to make life easier later. Trust me. In this example, maybe not, but in other examples, it will. Here, one single base raised to a power and then again raised to another power. When the two little numbers are close to each other like that, circle them and multiply them. So 10 to the 4 times 2, 10 to the 8th, which is 100 million. And then finally, x to the 4 to the 5th power. Okay, these two little numbers are next to each other, so you have x to 4 times 5, or x to the 20th power. Okay, so you have now 5 laws of exponents that you are going to be held accountable for. Okay, going back to the first page, you have the law of 0 exponents. For any number raised to a 0 power except for 0, it's 1. Law of negative exponents. We're going to flip it and make the exponent positive. This is one of the most difficult ones that students make mistakes on a regular basis. And then finally, those are the first two. The other three we have, multiplication law of exponents, like bases, multiplying together, add the exponents, division law of exponents, like bases, being divided, subtract the exponents, and then finally the power to a power law. Anytime you have two little numbers really close together like that, outside parentheses, circle them, multiply them together. Okay? Hopefully that was quick enough. Again, this is the second time I did it. I apologize for getting up there late, but you need to make sure you have this all down when you come back into class tomorrow. All right? See you tomorrow.